Hello everybody, I want to talk to you about clocking and clock dividers today. I'll show you the Karltron clock module, intended as a master analog clock with divisions. There's two of them here, 6 HP each. I can drive a sequence with this thing, and I'll take those divisions somewhere interesting. Each one has a free-running clock internally with two time control knobs, the coarse and the fine, to help you jog into position where you might need to be. There are four outputs. They are divisions of the primary clock. They're marked 1, 2, 3, and 5. The X1 is a primary frequency, X2 is halves. 3 and 5 relate to how many steps should be counted to drive the third output, and the last one is halves again. There's a CMOS flip-flop in there. An important feature is the optional input, so it can be driven by another, perhaps voltage-controlled source. And the master on-off switch, obviously. Here you see I have it triggering an envelope on maths to play this simple tone, which comes from saws, just one of those three saws, run through a comparator to turn the harsh saw into a nicer square, and then just a VC and a mixer at the output. The comparator gives you something nice, and maths is a very nice envelope. Let me show you what some of these divisions will do. I'm going to take that FM, move it to a drum, so you can see that the X1 is every second. And we can be more interesting if we throwing that FM back in every third. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Or 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I won't bother with the last one there. It's instant rhythms. The switches are just choosing the division, so you've got four options. An important feature is this input, so I've got that driving. This is a very fancy LFO giving a sine wave. The clock will take anything through a Schmitt trigger so that it'll square up. If you voltage control that, obviously it's going to get more interesting, so let's give it that last output. And you have a self-referential rhythm, which we could make happen. The off switch is actually an important feature, so you don't have to pull the cords out or mess up any knobs during a performance. And it's really been pulsing pretty constantly, so I'm going to show you some ways to make the rhythm more interesting. Take out all these green cords, and we're going to put the trigger to a mix out. Sorry, the trigger from this little mixer here. The DC mixer is just going to add some signals together, and we'll put the 2 and the 3, so we'll count off every second and also every third, which you can make your rhythms that way. If you have a probability module like branches, we could make an unstable rhythm, which is kind of fun. I'm going to pull this 2x to, 2 can stay in there, but let's take that every single, bring him down, and just fill that. I've got branches turned off, so we're only hearing the every third pulse. But branches will probability the primary, and we can put that in the middle. And you will get little trills or flourishes, occasionally giving more notes. You can do similar for pitches, of course. You can build a sequencer out of a clock and a mixer. So we'll just pulse straight off the X1. And then use the other outputs to set the frequency with the frequency mod input over there, which is a pretty nice little 2-note sequence, 3-note sequence, and you can set how much those go. These outs are like 10 volts each, so we've got to bring them back with this attenuator. Finally, you need to make use of a mult to really get everything out of a module like this. So I'm going to split the X3 up and then send it maybe occasionally to the maths fall time. I just said these are 10 volt outputs, so I'm going to attenuate it with this VCA. VCA without a CV, and it's just going to be an attenuator. And I kind of like that. Sort of repeating sequences built on each other. If you want to put a quantizer in there to get notes, that's up to you. The switches there are really going to change our whole pattern, but keeping in the same vein. I didn't even get to what you can do with multiple clock dividers. Obviously you can make strange intervals by driving one from the other. I'm going to take that last piece of the X3 and drive the previous module with it. And his X3 will affect the rise time. And you get a more complicated sequence. Still, I have no sequencer, no keyboard here. If you kill it, and he wasn't even running. So there's a lot you can do with some basic utilities. I think the analog module is so versatile. Let me end on something wacky. The subharmonic generator is, because this can just divide down whatever you've got, I'm going to take each one of the outputs and add them together. We're going to take all 4 of them added together. Kind of uses up your whole mixer, but this is a neat trick. And we'll listen to that. Run them. It's not running super fast, so we will also drive it. And now I've got a subharmonic. The primary, different amounts of a secondary, different amounts of a X3 note. Let me bring it up to an X3 note. Now this is voltage controlled, but if this mixer were voltage controlled or a VCA or something, you can imagine we can play with the harmonics really live. So that's just a long-winded demonstration of a clock divider. I'll wrap it up there. Thanks for watching. Can't help myself. It's too much fun.